Welcome back to Calculus. I'm going to work a few problems from 7.2 I think will be helpful. These were from the notes, but some of you weren't here for this, or some of you may just want another look at them. So we're going to do number 4 from example C, and this is a pretty familiar sketch here, where this was at 2, 8. This is our shaded region. Again, this curve is y equals 2x squared. That's what the curve is. This vertical line is y equals 2. And we are going to find the volume of this as it's rotated around this axis here, which is the x equals 2 line. Okay. So, let's see what happens here. And I'm not going to solve any of these, I'm just going to set them up. So, the volume is always pi times the integral. Let's see, our representative rectangle must be horizontal because it's going to be perpendicular to our axis of revolution. Therefore, we have a tiny height, so it's a tiny dy. So since it's dy, you can go ahead and put dy at the end here and know that this equation must be solved for y, so in terms of y. So x equals the square root of y over 2. So if you're in class, you remember that we don't need the plus or minus. The negative would just put us over here, and we're only going to look at the positive side. So that's going to be key. So our integral is going to go from their slices are going this way, horizontal slices, so it's going to go from this y coordinate of 8 to this y coordinate of 0 to y coordinate of 8. So those will be our bounds, 0 to 8. The next thing is we need to figure out what is the, normally I say height, but I guess in this case I'd say width of that red rectangle, which we call the representative rectangle. And all those yellow slashes there really could be other rectangles. I made them way too long, but they could be other rectangles too. That height, you might note at the bottom, I'm trying to explain this a little different than I did in class. The bottom, that has a distance of 2. At the top, right here, has a distance of 0. So you might be tempted to put in this equation here, but if we put that in, and you plug in y equals 0, you actually get 0, and that is not 0. So how are we going to get that? Well, what you have to do is you're not just taking the x coordinate, but you're going to have to do 2 minus the x coordinate. This is difficult to explain on here. Again, if I go back to the mile marker, I can't help it. Back to that. This is mile marker 2. This person's traveling on this curve. So how far are you from that person? What color have I not used here? So again, if we darken this representative rectangle here, that didn't really help. Trying to pick a unique color here. If I don't know. If I darken, if I look at the representative rectangle, the width is going from 2 to 0. So you have to find that width, you're going to do this right edge minus this edge, and that will give you your width. You see that it's getting smaller and smaller as x increases, going from 2 here to 0 here. So what is that going to be? It's going to be the right edge, which is x equals 2, so 2, minus the left edge, which is described by that equation. So the left edge is the variable edge. It's changing while the right edge is constant. And there's your setup. Put that in your calculator and you got it. Let's do one more. This is one I have not done in class. So even if you're tuning in for a review and you saw this in class, this will be new. Example 5. And I'm just making this one up on the spot. We're going to have the same look here, where this is the point 2, 8. We're going to find that area is going to be our region, but now we are going to revolve this around something kind of crazy. This axis, x equals 3. So just to show you what's going to happen here, I'll use a different color. This thing, when reflected, would look like this. Okay, so if you kind of imagine that ring with a curved edge, is what would happen there. So this is definitely a problem where we need the washer method, because we're going to cut out the inner radius. So there's our representative rectangles. Always, by the way, we are revolving around that. It's always perpendicular to your axis of revolution. So again, we're going to end up using that solved version, which was, what was it, x equals square root of y over 2, is that right? Yeah. So we're going to use that. But now the question is, what is our volume? It's pi. What are our bounds? Our bounds, again, are going to be 0 to 2. That's not changing. Or 0 to 8. Did I do 0 to 8 before? Yes, I did 0 to 8. Okay, that worried me. So they're going to go from 0 to 8. And this is going to be a dy problem. This, again, I'm going to write my little dy. This is dy. We are going to have two parts, though, here that are going to be squared, our outer radius and our inner. Let's see if I can do this with colors here. So the outer radius is for this representative rectangle. It's called representative rectangle because it's representative of the many or infinite many rectangles that you're going to add up. So the question here is, what is that distance there, that orange top line? What is that distance? What do we do when you want a distance? You're going to do your right minus your left. If it's vertical, your top minus your bottom, right? So if you are in the 11th grade and your brother is in the 6th grade, you are 5 grades ahead. You don't do his grade minus yours and say -5. We do the rightmost, the greater number minus the less number. So our right edge in this case is 3, and our left edge is described by the function. So simply, this is going to be, I have room for this, 3 minus square root of y over 2, and that's all squared, because 3 minus the square root of y over 2, that is the radius, and you square that. Minus, this is a washer problem because we need to subtract out the inner part, which is made up of this region right here. The thing with the inner part is, if you look at it, the representative rectangle appears to be exactly 1. If you move up a little bit, it's still 1. And you move down a little bit, it's still 1. It is a constant distance. So that's going to simply be minus 1 squared. And that's it. Simplify that. I don't know what the answer is, just made this one up, but that would be how we would solve this one. I hope that's clearing up some stuff. Keep trying the examples in the book. Keep at it. You'll get it. See you next time.
Made with Doodlecast Pro.